Okay, now we will be discussing curve fitting. In general, this lecture is about approximation of a function, meaning there is a relationship between two variables, and we try to create an equation or relation between those variables through curve fitting. So essentially, curve fitting is a way to see kung paano natin ma-express yung relationship of any given data set. Like, for example, this data were obtained through experiments or through other means. Essentially, the requirement is that to see kung ano yung relationship between those variables based on, for example, is rudimentary plotting. For example, you can plot those data in as points. So like for example, in this case, so you can plot these singular points, and in general, you can assume that the trend is increasing, going to the right. Another way is to connect them with straight lines, okay? Or a more advanced way is to create a polynomial that will pass through all those points. As you can see here, okay? And essentially, it follows all the raw data points that you want to fit, okay? One of the commonly used method is the least square regression. Perhaps you're familiar with it. So, usually this is done in experiments like in physics 100 series or even statistics if you've taken that class before. So now essentially it depends on the given data. If the data are really good, you can get a good approximation of that function. Okay. Now, of course, kung you're gonna do fitting, essentially to create a general relationship between those values, like by simply creating a line to describe them, you're actually doing what we call interpolation. So for example, in this case, you assume that the general relationship of these data points, you can create a good approximation of what is the value of the function between those given points. For example, this point and this point. You can simply connect this in a straight line, but if you create like a polynomial fitting, you're assuming that the value of your function is approximately at this point at the given unknown value of x, that is between those 2 points. So this is essentially what we call interpolation. So meaning these are assumed values based on the general relationships of all the given data points, right? Now, the most common approximation is called linear regression. So yun yung kanina unang example. So essentially, you want to fit all your data points in a single line. So linear, so just a linear equation. Okay, so given data points x1, y1 up to how many data points you have, you create a linear equation. So as for example, we have y equals a naught a1 x plus e. Yung a naught, of course, and a1 are coefficients. Since this is related to linear equation, a naught is actually the y-intercept. A1 is your slope. Okay. Now, e here is the error or residual. Meaning, of course, hindi mo kayang i-fit lahat. For example, this line, these data points, hindi mo siya kayang lahat na idaan sa singular line. So there is an error na related sa kung gaano kalayo yung data points mo dun sa approximated line mo. Alright? Okay. So, now, essentially, ito yung error. So, you have your regression line. So, for example, your data points are here, not exactly on the line, but in general. increase. Now, so you created a linear equation for that, and the error can be calculated through that. So you have a measured value of y, the actual data point, and you have the model, meaning yung sa fitting line ginagamit natin. And essentially what you want to do is to minimize that error. So we can create some scalar value called yung SR, okay? SR is actually just the summation of all the error square. So actually kaya siya least square. You want to minimize it. So you want to find the value of SR as low as possible, okay? Given yung mga error natin na E. Okay? And of course, dahil may equation tayo for y relating E, yung kaninang equation, you can represent that. So you have the y measured, your actual value, and the y model, meaning yung equation kanina. So essentially what you want is yung y sub I, yung raw data, for example, this one, and kung ano yung approximate mo doon na value na function. And you want to minimize this as much as possible. Kaya sa tinawag na least square. So this is a square term and you want to get it to be minimized. Okay. All right. So to minimize it, of course, is a calculus term. So what you need to do is to get the partial derivative. Okay. Partial derivative, kasi you have several variables in this case. Well, you might think yung A1 and A0 are constants. In that context, yes, but since you are approximating, you can treat A1 and A0 as variables too. So if you take the partial derivative of your SR with respect to A0 and also with respect to A1, okay, and then you equate it to 0, so that is essentially you're trying to minimize it, right, in calculus term. So take the derivative and equate it to 0, okay. Now you have these two equations based on that process, and you can solve this equation simultaneously, okay, because they are based from the same variable. So you now have these two equations, okay, and essentially you look at it, this one, no, you can see that the right hand side is the summation of the product of your values of x and y is approximated through this terms. So the first term is the summation of xi, all your values of x, the raw data, okay, times A0. And then the second term is the square, the sum of the square of xi, okay? All right. So now you can solve for A1 and A2 using those equations. Now A1 is a bit complicated, okay? So essentially what you need to do is to get the quotient of these two terms. So above you have the n times the summation of xi, yi all over n. Yung small n dito is the number of data points, okay? Times the summation of all the values of x times the summation of all the values of y, and divided by the summation of x squared terms times n minus the summation of all x, okay? Now A0 is simpler. This is just equal to this term, okay? Now, yung best fit na ibigay, of course, is because nag-minimize ka na. So, essentially, you can measure the best fitness of your regression through standard deviation. So essentially, the standard deviation small s is just the square root of your capital SR divided by n minus 2. N again is the number of data points. Okay. Okay. Next. Now, there's another way. We call it linearization of nonlinear relationship. Okay. So, for example, in this panel, you have a exponential relationship of y and x given by this equation, and you want to linearize it. So to linearize it, you actually need to take the logarithm of that. So essentially, as you can see, if you take the logarithm of this, you create another graph. So from y, you now move to ln of y. And then, mamumove lahat, syempre. In this case, meron kang y-intercept here. When you take the logarithm, your y-intercept changes, of course. Okay? All right, so for example, another nonlinear relationship is a polynomial. So you have y is a2x raised to b beta sub 2. Beta could be square, cube, but in this case, it looks like it's like a square. And of course, you take the logarithm of that, you now have a linear relationship. Another is the related to inverse. Okay, and you take the logarithm, you still get a straight line. So once you go through studying literatures for other courses or your thesis, you will somehow probably will encounter some data points that are shown like logarithmic plot. Okay, so hopefully you will see and understand kung bakit kailangan isulat siya in logarithm instead of the normal. Okay, now for these two cases, you plot the log. Okay, this one is ln, of course. This one is the logarithm, depende doon sa base, like b2 or beta sub 2, sorry. And for this one, this is actually different. You take the inverse of that. Bakit kaya inverse? Kasi you have this particular equation. So if you take ln, medyo magkakaroon ka ng dalawang terms, so medyo komplikado. So you just linearize it. Right? So instead of y, you now have 1 over y. And instead of x, you have 1 over x. Okay? There's nothing wrong with this. You are just actually presenting the same data set. Okay? Sa upper row, well, obviously, kung ano yung x and y, yun agad yung data mo. But for the second row, you have a different value, but you can still obtain the values of those original like y and x. Okay, you just need to do some mathematical operation. All right. Okay, let's continue. Okay, so an example. If you have an equation, y equals 1.35 times x raised to 1.75. Okay, so this is this is close to parabolic relationship. Now, the original values of x and y are given here, so you can try to calculate that. Now, if you take the ln of x and ln of y, you now have different values. And if you plot the original function, you can see it here, it's a near parabolic equation. And now if you take the ln, it's now a linear equation. Okay? So hopefully familiar pa kayo pag kinuha mo yung ln. Once you take the ln, bababa yung exponent, and then product is actually the sum of those ln. So you now have these two ln. Okay? All right. So another type of fitting is called polynomial regression. So kanina linear regression lang yun. Of course, you try to fit it on a single line, straight line. Now we have a polynomial regression. Of course, the limitation of the linear regression, is actually just you're assuming that there's a linear relationship. But somehow in other data cases, for example, you're doing an experiment and you want to compare it with a theory. And of course, you know that the actual relationship of those data is not linear, but rather, let's say, square or cube. So therefore, you need to use polynomial regression. Okay? So okay, just a side note, you only use linear regression if you know that the actual relationship of those data is linear, or you're doing some experiment that you have no idea that of the actual relationship of those data, but it looks linear, so you just use linear regression for that. Okay? Now, if you know that they are indeed not linear, you can use one of the method uses polynomial regression. So you just extend the equation. Initially, you only have up to the first term. So you can actually treat linear regression as a polynomial regression. You only have a polynomial that is of degree 1. Now you add another term for the polynomial. So in this case, this is a quadratic polynomial, second order regression. And do the same thing. You express the residual. Okay, so you subtract the measured value of your y minus the model. So ito siya galing. Okay? Huwag natin isama yung i pala in that case. Yeah, kasi y lang muna. Now, to get the least square, of course, you take the partial derivative again. But since you have 3 coefficients, you now have 3 partial derivatives with respect to those coefficients, A0, A1, and A2. Okay? Now, doing the same process, you will have these 3 equations. Okay? And by doing so, you can actually get the values of A0, A1, and A2 based on these equations. Okay? Now, the good thing about this, as you can see, is actually somehow it looks like a system of equation, right? Because all of these variables are related to each other. So you can actually write it in matrix form. Okay? So that way, it would be easier to solve for your A0, A1, and A2. Now, of course, if you increase the degree of polynomial, you will have more A here, so A3, A4, etc., and you will have more terms here. Okay? But if you can express that and you now have a system of equation, then using the method for matrix that we did before, you can solve it, okay, much easier rather than manually. Okay? So for this case, this is only for the second degree, so quadratic. Now this deviation is a bit different. So kanina sa linear, this is actually -2. Now when you go to quadratic, this is -3. That's a slight difference. Okay? All right, so let's continue. Now for any degree of polynomial, ito yung sabi ko, you now have more terms sa matrix mo. But essentially, you can see the pattern here. Okay? So, for example, all the first row are summations ng x sub I with increasing degree doon sa x. For example, dito n lang, but you assume that this is just 1. Okay? Now, this one, ang power nito ay 1. This is 2, and sunod 3, and then hanggang m. Okay? Now, for the second row, it's a bit different. So, parang nag-move lang to dito. Ito dito, and so on. Parang nag-shift ng konti. Okay? Then, ganun din dito. Nag-shift lang ng value. So, all of these are just some of values ng x na naka-raise to some integer. And dito, of course, your a's, your coefficient. And yung constants mo are actually related to x and y. So the first term is just x, y. But you can actually think of it as mayroon kang xi raised to 0. Kasi dito magiging xi raised to 1. Dito magiging xi raised to 2. And hanggang xi raised to m. Tama? So yeah, there's a pattern there. Now in general, the standard deviation is actually SR, square root of SR over n minus m plus 1. So kung ano yung degree? So kanina, kung quadratic, this will be 3, so n minus 3. Okay? Now kung linear siya, so 1 lang to, so n minus 2. Alright? So that's it. Okay, so now, for example, you have this data, okay? So you assume that this has a second order relationship. Of course, you can plot this first to see actually, but you can have a rudimentary estimate. For example, if x is 0, 2.1, 1, and then 7.7. As you can see, hindi siya simple na linear. It looks like nag-increase, but not too much like exponential. So Now you calculate now. So m is 2 because your second degree polynomial. N is 6 kasi you have how many data? 1, 2, 3, 4, 5, 6. So this is n. Okay? Then, of course, you need to follow yung sa ito. So you need to get all this. So n, summation of x squared, etc. So just doing so, yung n muna, so 6. So summation of all xi is 15. So i-add mo lang to. So you have 0, 3, 6, 15. Okay? Then summation of y, add mo to, you have 152.6. Now the others you can do in MATLAB. So for how do you say it? For x squared, so 55, x cubed 2.225, x to the 4, 979. Okay? So let's see. Okay, so hanggang x to the 4 lang yung kailangan mo na term. Now the others, you have to manually do that. You can use Excel or MATLAB na lang. Pwede rin. So, usually madali siya sa Excel kasi meron kang row, tapos gagawa ka lang ng mga column mo. Right? Now, so for x times I, sorry, xi times yi, you have 585.6. X squared yi is 2488.8. So you now created the matrix that you need. Now, by this point, since you already have, like for example, LU decomposition, you can use that to solve for the values of your coefficients. Once you have the values of your coefficient, you now have the function for fitting or the quadratic polynomial fitting. So originally, this is y equals a naught plus a1x plus a2x squared. So pinalit mo lang kung ano yung nakuha mong a1, a0, a1, and a2. Then you plot this. So you can plot this along with this data and makikita natin. For example, estimate lang, let's say pa ganyan. And your date plotting, let's say since second order pa ganyan. Okay? So you have your raw data and you have your function that you want, you try to fit those data in. All right? Okay. Now, let's talk about polynomial interpolation. Now, of course, interpolation is you try to get the data between those given points. For example, these 2 points, ina-approximate mo yung value dito. Now, for 2 points, the easiest way would be linear fitting. If you have 3 more points, of course, for example, in this case, hindi mo siya kayang i-fit into single line. So the best fit here is quadratic. Now, if you add more points, so essentially you can actually do linear here, but medyo malaki error. Now, the common is to create a polynomial. So this is actually like a order 3 or more. Okay? All right, so now essentially it depends on the order. So the unique nth order polynomial that fits n plus 1 data points. So habang nag-i-increase yung data points, it's related to, let's say, n plus 1. So you have, for example, degree 1, so you have 2 data points. Degree 2, so you have 3 data points. And degree 3, you have 4 data points. Okay, so ganun lang siya. Okay? Now, meron tayong method for interpolation. So this actually goes back again to Newton. So we have Newton's divided difference interpolating polynomial or linear interpolation. So you want to connect 2 points, then the simplest way is to use linear interpolation. Okay. Now, for example, you have these data points. Okay. The easiest way to connect them is just a straight line here. Okay. Okay. Kung hindi mo napansin itong pa-curve, like yan. So, okay. Now, how does it work? So this is just related to derivative and slope of a line. So for example, you have this given points x0 and xi, okay? So you can actually get the slope. So you have f of x1 minus f of x0 divided by okay, so you have those 2 points, but to have a better fitting, you need to interpolate. So in between, you have an unknown value of x, or you just assume which one. So usually like half, or depends, no? So to get the slope, for example, here, so you are relating your f sub 1 of x minus f of x0 divided by x minus x naught. Okay? Then, of course, kung gusto mo siyang nakafit sa single line, dapat yung line nakasunod, like from here to here, okay, from here to here is the same slope as dito. Okay, and to do that, you have to equate the equation. So you have f of x1 minus f of x0, the whole line pala, sorry, yeah, and x naught, x1 minus x naught. Okay, now, since gusto mo interpolate, you need to create a function. So ito yung unknown function mo, f sub 1. By rearranging this equation, you can have a linear equation for this. And this is actually the linear interpolation formula. Now, if you remember yung ginawa natin sa Simpson's rule, we have a polynomial fitting there, right? So this f1, so of course there is f sub 2, f sub 3, and so on. So this subscript denotes the degree of interpolation that you're gonna use, or you'll be using. Okay. All right. So example, you have these values, no? So yung black lines, sorry, the true value are, in this case, is this one, okay, this one, and this one. So it looks like parang natural, yeah, this is natural logarithm nga, tama. Logarithm of 2. So it says here. Okay, now the linear estimates can be taken through, just get the logarithm or ln. Okay, so what you need is to connect those points, no? So for example, gusto mo kunin yung line relationship from here to this point, no? So kailangan mong i-define. So your x0 is actually just 1. Your x1 here is 4, as you can see here. Okay? Then another, of course, later, kung gusto mo i-extend yung interpolation, like for example, up to here, that is 6. Okay? Now, getting the values of those, madali lang kasi ln, hold on, this should be x. Okay? All right, so palitan mo lang sa ln, you will have these values. Okay? For x1 and x2. For x0, madali lang naman. N, 0 lang din kasi 1. All right, so now you have this equation na obtained kanina. Just plug it in, and you have this particular equation. Natural logarithm of x at x equals 2. Para hindi kayo malita. Okay, so you're trying to approximate the value of that. So you have 0.3583. Okay. Now this is a large error. Okay, this is 48%. That means because you use yung kasi ang value mo is actually here. Okay? So the actual value is above those estimates. So yung unang ginawa is nandito. So medyo nasa baba siya. So it's around 0.35. Ang f sub 2 of 2. Okay? Now, if you increase the interval like the range like from 1 to 4, kanina is only smaller pala, sorry. So the first one is like 6 minus 1. So here to here, so ini-interpolate mo yung data dito. Okay? Now if you use like 4 to 1, so mas maliit, medyo mas tataas yung estimate mo na value. So you have 0.46, which is about 33%. So medyo malaki pa rin yung error. So that means if you want a better estimate, kailangan mo pang mas bumaba dito. So let's say 3 or 2.5 hanggang mas malapit. Okay? So that's it for the sample of interpolation. Okay? Now, that is the previous one is for linear interpolation. Now for quadratic interpolation, you just increase the number of terms, pero medyo mas komplikado siya. So you can write f sub 2 as this equation, and you can generalize it. Okay, may ganyan siya. Now, para mas simple siyang tingnan, you have to write it in standard form. So you have A0, A1, A2. Okay, but based on this equation, yung A0 is equal to this, A1 is equal to this, and A2 is equal to this one. So all of these are actually constants. No? So B0 is your coefficient there. X sub 0 is the initial value of X. X1 is the next one, and so on. So you have this equation for that. Medyo mas komplikado siya ng konti. Okay. Now, to determine the coefficient, okay, pwede natin gawin is you assume, let's say, for example, the value of X. You set the value of X individual trial to get some values. For example, if you set X as X0, this term will vanish. So ano matitira? So you have B sub 0 is actually F sub 2 of X0. Okay? Now B1, pwede mong makuha siya, palitan mo lang din ng X1 yung X. So ito naman yung mag-vanish kasi X1 minus X1 is 0. So matitira sa'yo ay itong first two terms. You now have values for B1. Now for B2, ganun din. Palitan mo na ng X sub 2. Pero mas mahaba yung equation. But still, you can see the pattern. So for B2, you have X2 minus X0. Sa taas, X2, X1 divided by 2, 1. Then minus siya ng 1, 0, 1, 0. So there's actually a pattern there. Okay? Now, yung kaninang problem, the logarithm ln of 2. So instead of linear, we use quadratic. So if you plot the quadratic equation na makukuha is actually dadaan pa ganyan. So yung true value is somewhere here. So tignan natin kung ano yung estimate. Now listing all the values that you need, 0, x1, x2. Then ito pa rin yung kanina. Then may equation na tayo for B0, B1, B2. Okay? Getting those values, palitan mo lang those standard equation. You have that particular equation, and estimate ng function natin, palitan mo yung x ng 2, you have this. So it's a better estimate. So 0.57 somehow. And if we zoom in here, if this is 0.57, that means this is so tingnan natin so 0 to 1, hinati sa 1, 2, 3, 4. So 1, 2, 3, 4, 5. This is 0.2. Tama ba? Okay, so this 0.2, 0.4. Okay, so medyo may mali dito sa estimate lang ng plot. Okay, let's see. Saan yung kalahati? 0, 0, 2, 5, 0.5, 0.75, 1. So that supposedly this is 0.2, 0.4, 0.6, 0.8, and 1, no? But the estimate sa quadratic is actually 5.56, so it should be above. Oh yeah, tama lang. Should be below, so below 0.6 so here. Tapos yung estimate kanina sa linear is a bit below that, so 0.4 something. Okay, so you have these estimates. Okay, so we have a better estimate using second order. Okay, all right, let's continue. Now, in general, you can have any degree of polynomial. So medyo masahaba na equation. So for 3, degree 4, degree 5, etc. But there's a pattern here, and you can generalize all of those equations. And the coefficients would be like increasing. For example, for first order, you have this. Second order, tatlong variable na yung dependency. Third order, you have 4 not really variables, rather values of x, yung finite difference, yung hati-hati. Okay? All right, so that's it muna, no? Now, the next discussion is actually nagawa na natin yung brief process. It's called Lagrange interpolating polynomial. So, nakapag-plot naman kayo ng f second degree actually, hanggang third degree ata. Yeah, so that's for the next topic. So, thank you, and I hope you just study this, and if you have questions, you can just ask in class or consultation or email me. All right, so thank you very much. Stay safe.